Hello, everyone. So what I'm going to talk about is how Postmortems help hardening our k8s clusters. So first of all, who am I even standing here? So I'm Marcel. I'm a platform engineer at GiantSwarm. And of course, the first letters you saw were Kubernetes clusters. So I said Kubernetes clusters. We talked about them so much so far. So at GiantSwarm, we manage and create Kubernetes clusters for our customers. So that means we have by now 130, 140 Kubernetes clusters in different sizes, running on AWS, on Azure, on KVM, all fully managed by us. That includes many large clusters. So I'm talking about production-grade clusters that big enterprises use for their web front ends, for example. Which also means they need to be production ready. So 24/7 monitoring on our part that the clusters are actually functioning, and day 2 ops and everything that comes with that. Now, when you run many clusters and you do many exciting things with those clusters, many things can break. So failure is basically a constant in that sense. We have alert channels that are just getting message after message, and how do you deal with that? So now we come to the concept of postmortems. What even is a postmortem? So the actual incident has already been resolved. So someone got paged at night, saw this cluster is on fire. He put out the fire, so there's no more fire in the cluster, but now there's a root cause, and what do we do now? So someone just already fixed the problem, like put a band-aid on it, but it's not really fixed. He just kind of made sure that it's no longer burning. Of course, we didn't come up with the concept of postmortems. Some smart people at Google did, probably. So from the Google SRE book, they wrote down a postmortem definition. And there's basically 3 important steps in a postmortem process. So the first step would be the incident is documented. So there was a fire, and someone documented that the fire actually happened, and also where the fire was and what possibly started the fire. Secondly, all contributed root causes are well understood. Now that's further down in our postmortem process. So we start with documenting. Hopefully we eventually understand why the fire started. And then at the end, we take some preventive actions to hopefully make sure that the fire doesn't start again. So how do we at GiantSwarm implement this postmortem process? So the first step, of course, would be incident documentation. And now this is basically me telling you how we do it, and hopefully you gain some value from it. We use a GitHub issue. So once an incident has happened, the person that responded to the incident, so an on-call person, could be me, so I get woken up at 3 a.m. at night, something went wrong, I fix it hopefully so that it's no longer burning. I go to GitHub, I open an issue with like a label, postmortem, and I have a template to fill out. I note down who worked on it, so me. I note down which actions I took to get rid of the fire in the immediate sense. And then I include some explanations of like what I think might have happened or what I saw. I include links to, for example, Slack, when we had conversations on Slack. So everything that happened during the incident or during the time of the incident, I try to document in this issue as like a single source of truth. And then I also try to estimate like the impact of reoccurrence. For example, did the whole cluster break? That's pretty bad. And if that happens again, that would also be pretty bad. Did only some service inside the cluster break? It's still kind of bad, but it's not super bad. So kind of finding an estimation of like which level of impact are we dealing with. Once this has been done, so the incident has been documented in a GitHub issue, we now get into the beautiful part of who's responsible. So we have cross-functional teams, as you can see here, very beautiful names of Team 1, Team 2, Team 3. And the postmortem gets assigned to one team. We do this by each team having a specific mission. And the person that first created the postmortem or had the incident can decide which team mission fits. Very simple team mission, for example, we have one team mainly dealing on AWS clusters. So if something AWS specific went wrong, well, it's most likely going to end up in the AWS team, right? So that's what we do, and inside the team, the little colorful person is the PO most likely, who can either decide who gets the issue or the team can decide independently, okay, who's going to get assigned this postmortem. Postmortems in general for us are the highest priority issue you can have in your team. So that basically means you get assigned a postmortem, you should deal with it as quickly as possible. So other team stories go into the backlog potentially, and you decide, like, if it's a high severity postmortem, work on it immediately. So now we did the documentation. We also found someone that's kind of responsible for now. So now we start, or the person needs to start finding a root cause. And that is sometimes not trivial, obviously. There are a few guidelines we like to follow. Firstly, only use the GitHub issue as a continued source of truth. If you spread out what you did and what you found through different sources of truth, stuff can get lost. Someone looking at the postmortem, like in 5 months' time, when the same issue somehow occurred again, is going to be very confused. So keep it as one source of truth, and that's for us a GitHub issue. And on top of that, well, time box your effort for finding it. Of course, these issues are bad, but as we saw in the beginning, also some mitigation is necessary for us. So always time box, well, how much effort do I spend actually finding the true root cause before finding some mitigation? And something that's very important, kind of common sense, would be always pull people in. You might be assigned to the postmortem, but it's not now your sole responsibility to solve this on your own in a cave. You have other co-workers, you can ask them, you can talk to them, they are smart, they can figure it out together. The ideal result of this step would be you are able to reproduce the issue in a safe environment. So on a test cluster or on a test installation, you're now able to reproduce this issue. Ideal because, well, as ideal cases are, that doesn't happen so often. So now we come to the third step, which would be, okay, we take preventive action. Here we have a very hard rule in our company to time box this to 2 hours. Why 2 hours? We don't want the person just working on a postmortem to spend the next 2 weeks trying to fix it, when during that time there could be a reoccurrence, which would still be bad. So even small steps towards making it better are very good. We get to the 2-hour point later on again. So what are some examples of like mitigations you can take or preventive action you can take? Well, first of all, you just fix the issue. That's like, wow, done. Don't have any more problems. You can add an alert. This is easy on Kubernetes. You can have like your Prometheus set up. You add an alert for the specific case that happened if there are metrics for it, and then maybe next time you notice earlier that something's going wrong, or you make some improvements. Now, even worse than adding an alert maybe is like you disable some feature. Like maybe you disable a feature gate, maybe you remove a service completely to ensure cluster stability. That's of course not so nice. And the final step, or one final example I mentioned here, is just communicate internally and externally that the problem exists. So if it happens again, someone can take action quicker than you did when you needed to find out how do I actually put out this fire. Now you documented, okay, this is the steps to put out this fire. Let's look at this preventive action in a little example. You might be familiar with something like that. Who here uses Alert Manager and Slack maybe? Someone at all? Yeah, that's a few people, cool. So this is our Alert Manager integration and Slack. What we see here is we got an alert, which is like control plane, daemon set not satisfied. It's just like a daemon set that should be satisfied is not satisfied for a long time. So 30 minutes or so. And we see down here, okay, it's on fire. See the fire emoji, that's very on fire. And we also see there's a Calico node, which is quite critical to have running in your cluster. And down at the bottom, we see 4 buttons, which should help you debug and solve the issue or put out the fire immediately. The first button we get to in the next slide, query, will take you to Prometheus to kind of check out like the Prometheus graph and see what's actually happening or according to the metrics happening. Third button just puts you to Grafana, so you can check out some Grafana dashboards that are related. And the fourth button is just, maybe it's a false alarm or you don't care and you can silence the alert, okay? So there's like grades of how much you care, basically. And now what I really want to talk about, the first one, something we do is an ops recipe. That's basically our means of communication, that something went wrong and now I want to basically document the steps on how to fix it. I chose this alert for a specific reason because it's a false alert, okay? What I mean by that is I personally wrote an ops recipe, which is also on GitHub and would open up when you click this ops recipe button. It's internal for us, so if you're interested, I can just leave the slide open a little bit. It's basically a bug in a kubelet from Kubernetes 1.15.4 to 1.15.6, so a very small range, and after that it's fixed in 1.15.8 already. And these are just some mitigation steps on how you can find out that it's happening and how you can mitigate it, which is basically just restart the kubelet. What this does now is help us when someone else encounters this problem, they already see like this information I've written down here right away. They can go ahead and put out the fire, hopefully very quickly without much effort. So, and the final step would then be, okay, we had some mitigations. The best mitigation was obviously we already fixed the issue, but that's pretty rare. Often the issues are like a potentially bigger story. Like I'm talking a deeper problem. Like you don't usually just upgrade a production cluster from 1.15.5 to 1.15.8 or 9 if the customer has some very sensitive load on there, which might happen. Or if you need to upgrade this for, let's say, 20 or 30 clusters, that can take from days to weeks sometimes, depending on customers, obviously. So because of that, we usually then create a bigger story out of that, but we have a follow-up from the postmortem, and we basically plan during our team planning how to proceed with this. So inside our cross-functional teams. Now some post-mortem realities and some stats. In Giant Swarm, there were in total 1,183 closed post-mortems so far. This is like a time span of 1.5, 2 years maybe a little bit more. So a lot of post-mortems and a lot of stuff going on. We currently have open 42 post-mortems. Still quite a lot, but compared to 1,000, it's okay. 99% of the postmortems that are actually happening are very boring. So when you read a GitHub blog post, like we saw this morning, of like very interesting postmortems, 99% of the time, it's the complete opposite. It's something very boring. A rule we have implemented for ourselves in our company is if a team has more than 5 postmortems, they focus on nothing else but postmortems for the entire week. This is kind of a mitigation for us to really ensure that a team is setting postmortems as their highest priority and setting this level of stability as their highest priority. Might make sense for us, does not probably make sense for everyone, but this is something we do. Takeaways from postmortems and our postmortem process, or I presented here. In our experience, a structured process helps us share knowledge internally. We have these GitHub issues, they are findable. When an issue occurs again, you can just search in GitHub for like, I don't know, Calico node down, you find maybe 3 or 4 postmortems, maybe more, and the knowledge that already someone else acquired a few months back is still available for you because it's all in one place. For us, we noticed that stability dramatically increases when we have a structured and stable process of how to deal with a postmortem of an incident. When we don't use postmortems, or our experience of not using postmortems was there was an incident, someone was responsible, but maybe the fix got lost somewhere, or maybe just like someone just fixed something at night, was too lazy to create a postmortem, or was too lazy to document it correctly because it's 3 a.m. and you want to sleep. And then this just gets lost, and it happens again and again and again, and your customers are not very happy because the stability is just not great. Finally, on the positive side, this is like a company culture thing that I think is very valuable for companies attracting people. So a no-blame culture. Is everyone aware what a no-blame culture is? Just like quickly raise your hand if you're aware of that. Yeah, I would say everyone's aware of a no-blame culture. Postmortem synergizes very well with a no-blame culture because instead of assigning blame to a specific person, you just document what happened in a systematic way where basically not a person was at fault for doing something, but it's actually a system problem, and it's treated as a system problem by the team responsible for it. In my experience, that helped a lot with a no-blame culture and keeping that up. Your mileage may vary. The final takeaway, which is kind of a mixed thing, fighting fires versus fundamental improvements. It's very easy to get into a situation where you're only working on postmortems and you're not actually fixing the core problem. You need to be aware of that. So the postmortem process is not something you can blindly just do and then you do every week, you just do 10 postmortems every week and you don't develop anymore. You need to be careful that you don't run into the problem of just fighting fires. And that's something that needs to be communicated by the team, the product owner, and inside the company. In my opinion, one of the biggest challenges still, for us at least, with postmortems. And with that, I say thank you very much. Quick attribution, Pooya Abbasi basically had the first idea for this talk and the first rendition of this talk, so I stole some slides from him, and you can stay in touch with me here. Any questions? Yes.
I don't know if I get the calculation right. You said 1,000 postmortems in 1.5 years, meaning, I'm not sure if I calculate that right, but 2 to 3 a day. And the question is, what is the threshold that you set to react to that? Is it just alerting, meaning there's something wrong in the cluster, or what is the trigger where you say, yes, we do that, and no, we don't do that?
So I'm not sure about the 1.5 year or 2 year. Time flies, let's put it like that. We usually define a postmortem if a human had to intervene with the cluster. So if it's like an automation where, I don't know, it's self-healed over time, we don't necessarily create a postmortem. If someone got woken up at night and then it's self-healed, then we create a postmortem, for example, because a human had to interact, and if it's just looking at the cluster and seeing, okay, it's self-healed, that's still, I don't want to wake up at 3 a.m. and see that the cluster is self-healed now. So that's usually the threshold of, okay, there was some human interaction involved, but there can also be cases where a postmortem gets created for just issues where we're wasting time, so to say, where a human is interacting with a cluster that should be automated in a cheap and easy way. So that's basically where we cut the line. Any other questions? Yeah. Can I have the microphone?
Sorry. Just to build on top of, from my experience, I'm not sure whether you're doing retrospective or not at the end of sprint or how do you work, but what helped us is to look at the problem proactively, extrapolate to the whole type of problem. Let's say it was a storage in one cluster, maybe we will have similar problem in other cluster, and to take approach on a more generalized kind of grounds.
So yeah, taking more general action is what I meant with like the fighting fires with this actual improvements. So sometimes you just need to take a step back during retro or whatever and figure out like we're just doing postmortems here. One example I could maybe name there is, as some of you may know, k8s has kind of died now, and with that there's also no longer an update of the Docker version of k8s. So what we have been hitting in the past was that there are known Docker bugs which are already fixed in more recent versions of Docker, but were not brought to any recent versions of k8s. And then switching away from k8s to a system that actually has a more recent Docker version. So sometimes we need to take a step back and just rethink, like, what are we doing here? Any more questions? No? Cool.
Many thanks.